A lot of the problems this evening involve taking the derivative of functions that involve absolute values. So I wanted to walk you through the process of doing that. Whenever you're taking the derivative of something that has an absolute value in it, the easiest thing to do is to start by rewriting it as a piecewise function. And you do that by saying, hey, this absolute value has an x inside of it. So when the thing inside is greater than or equal to 0, the absolute value leaves it alone and will spit out just plain x. So that means that this term here would be just plain old 6x because it spat out the same thing that was on the inside and there was already a plus sitting here. Now, if the thing inside the absolute value is negative, then this term, the absolute value would multiply what's inside of it by -1 to make it positive. So that would come out as 5x squared minus 6x, because it changes the sign of that, minus 3. So then when you go to find the derivative of this thing, you now have something that you can take the derivative of each part using rules that you already know. So the derivative of that top part would be 10x plus 6 when x is greater than 0. Remember, you don't include the domain break until you know that it's the same number from both sides. And then 10x minus 6 would be the derivative of that bottom thing when x is less than 0. So if I looked at 0, if you look at from the left and from the right, the derivative from the right would end up being 6, and the derivative from the left would end up being -6. So those are two different numbers. So the f prime of 0 is undefined, and actually it goes to two different numbers, so that means that this would be a cusp. But that's how you take the derivative of a function that involves absolute value. You rewrite it into a piecewise function, and then you take the derivative of each piece, remembering to leave the domain break out until you know that the numbers are the same from both sides.